Hyperactive threat detection is not a disorder. It is a survival algorithm running beyond its original environment. The brain evolved under asymmetric risk. Failing to detect a predator was fatal, while detecting a false threat was merely costly. As a result, neural systems prioritize sensitivity over accuracy. The amygdala flags danger before conscious awareness, long before evidence is evaluated. This bias made sense in ancestral environments, but in modern contexts it misfires, treating ambiguity, uncertainty, and randomness as danger. Understanding this mechanism explains why fear spreads faster than facts and why threat perception often overrides rational judgment. Threat detection circuits operate faster than cortical reasoning. The amygdala receives sensory input milliseconds before the prefrontal cortex can analyze it. This temporal advantage ensures rapid reaction but undermines accuracy. Once threat is detected, stress hormones bias attention, memory, and interpretation toward danger-confirming information. The brain does not ask whether the threat is real. It asks whether hesitation could be fatal. This is why reassurance fails under fear. Science must work against this timing asymmetry, slowing cognition to allow evidence to compete with instinct. In modern environments, hyperactive threat detection generates false alarms. Abstract threats, data, news, symbols, narratives, trigger the same neural responses once reserved for predators. The brain cannot distinguish between physical danger and symbolic threat at the emotional level. Chronic activation of these circuits produces anxiety, vigilance, and belief rigidity. Once a threat narrative forms, contradictory evidence is suppressed. This explains why fear-based myths persist despite overwhelming data. The brain protects perceived safety, not truth. Hyperactive threat detection shapes belief by narrowing attention. Under perceived danger, the brain prioritizes speed, certainty, and group alignment. Complexity collapses into simple explanations with clear enemies. Agency attribution follows naturally. Threats require agents. This is how conspiracies, moral panics, and ideological extremism gain traction. The belief feels true because it feels protective. Scientific thinking demands the opposite: broad attention, delayed judgment, and tolerance for uncertainty. These are neurologically costly under threat conditions. Scientific literacy is not merely intellectual, it is neurological retraining. It teaches the brain to decouple uncertainty from danger. This requires strengthening prefrontal regulation over limbic reactivity. Practices such as probabilistic thinking, controlled exposure to ambiguity, and delayed interpretation reduce false threat activation. Mastery is achieved when the brain can encounter uncertainty without manufacturing fear. Only then can evidence replace instinct as the dominant guide. Hyperactive threat detection built civilization's foundations, but unrestrained, it now limits understanding.